So in this part we will learn how to make forces, constraints, arbitrary components and nodes. So now go to geometry, select nodes, and in the nodes create the nodes. So the nodes that I want are at a distance of 150 mm on both the sides. So create 150, create, and now return. Now you can see the nodes have been created over here. The nodes that I have created are for the RB3 components. The RB3 components are the components that are used to distribute the load equally on the each element. So right click and then component. We need to create a new component for the RB3. So go to 1D element, select RB3. So instead of distributing the load on each element, we create a RB3 component that will distribute the load from one node to many nodes. Now first, for creating the RB3, select a dependent node and then select the independent node. Now as you can see, you can select the nodes manually, or you can select the faces on which the force is going to be applied. Okay. And create. Now for making another RB3 component, on the other side we need to make another component. So let's make a component over here. Again select a dependent node and select the faces on which the force is going to be acting. And create. As you can see, the RB3 components are created. Now we need to assign forces to those nodes. So to assign the forces, you need to create a load collector. A load collector need to be made for the constraint as well as for the forces. So next go to analysis and select the forces. Select the node on which the force is going to be acted. Give the magnitude of the force over here and create. Another force is acting on the another point, so in the negative direction, which will create a torque. The node wasn't selected, so the error had come over here. Now the node is selected and the forces are moved. After that, we need to give constraints. So for that, we need to create a load collector, SPC. So make sure that the new load collector that we have made is the current one. You can see the current where the component 2 and SPCs are the current. So now go to constraints, select nodes over here, and you can select the nodes manually as we selected the faces over here, but we'll say click on the loops because it easily selects the 6 holes that I want to select. So all these nodes are selected. Now we need to consider all the 6 degrees of freedom. So take those and create. Now you can see the constraints have been created. Now go to return. After the load and loads component and everything is done, you need to create a load step. So in the load step, select SPCs and load. In the SPCs, see to it that the correct SPC is selected, and low. Okay, so create. You can see a load step is created over here, and then go to return. Now we need to see the composite stresses and strains. For that, go to control cards and go to global output request, and in it select C strain and C stress. Select HD3 format or any other, but see to it both the formats are same. Go to return. The whole setup has been done, so now we need to run the analysis. So for that, go to OPTISTRUCT and run the. But before that, if we need to check whether all the plies and the direction and the orientation are proper, so for that, go to by property and go to composite layer with fiber direction. Now as you can see over here, the number of plies over here are 8 as we have created over here. Okay. So after that, make sure that the layers are off again and compare, because it will increase the computational power. Now run the analysis and OPTISTRUCT. Yes. Once the analysis has started, you can see the progress over here. And if there are any errors, they will be popped over here. And as you can see, there is a displacement of about 0.028 mm. Then we can see the results by going to HyperView or clicking over here. In the next part, we will see the results.